Okay, good. Now we continue looking at multiplying a vector by a scalar, and this is where we left off in the last video. Suppose now we consider looking at the horizontal and vertical components of these vectors. The original vector is AB, so we have AB. It is equal to, and we look at writing it in the form of a column matrix. Going along here, the horizontal component is 1, 2, 3, 4, and the vertical component is 1. So we can write vector AB as 4, 1. So it is 4, 1. Now, what we have here is negative 3AB. Remember, you have, if you're going along this vector, you would start here and end up here. So you go this way. Now, let us look at negative 3AB. This new vector, negative 3AB, equal. What is negative 3AB? In terms of a column matrix, writing it as a column matrix. In other words, as a column vector. Let's look at the vertical component. We're besiding this end. Let's go down until we are right beside this other end. 1, 2, 3. We go down 3 to get to the vertical component. So y is 3. Remember, it is in the form x, y. So y is 3. Horizontally, how do we move? Oh, by the way, we were moving down, so it's a negative that should be here in front of the 3. Now, as we move below this end to this end here, we have to move to the left. So the number before this will be a negative. How many units do we move to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to reach the other end of the vector. So it is 12. You see that? Now, let's look at negative 12, negative 3. Let's try to compare it with this, with 4, 1. Suppose we write 4, 1 here. In order to make 4 become 12, we multiply it by 3. In order to make 1 become 3, we multiply it by 3. So it's 3. And then we see that these numbers are negative, so this 3 must be negative. Do you notice that negative 3AB is equal to negative 3 multiplied by 4, 1? So we could say negative 3 times 4 gives you negative 12. Negative 3 by 1 gives you negative 3. Because it really amounts to negative 3 by 4 up top here and negative 3 by 1 down here. To get the negative 12, negative 3. It's just that we're going backwards this way. Alright? Because we wanted to see how this vector relates to this vector. So that's what we have. we can just write the horizontal and vertical, that is the x and y component of the vector, and just multiply each number by -3. Right? Now, let's do it again with a different vector. Let me erase these things here. Let me erase part of the board. Oh, I don't want to erase this part. Let me put back this part of my bracket that I had erased and just erase all of these things up here. Now, let me get rid of this and this dot. If we multiply AB by 2, what if we multiply AB by 2? What would happen? You know, of course, that we would have twice a vector which is twice the magnitude of AB, and it should be in the same direction, right? So this is AB. Remember, we had copied AB long time ago, so this is also AB, and if I paste again, we have another AB. So going all the way is 2 times the magnitude of AB, and the direction is the same. So let me put the direction here. So we have this long vector here, which is twice the vector AB in magnitude. Now, this vector is 2AB. If I should write 2AB in terms of a column matrix, I would say 2AB equals, let me put the arrow at the top to show that it's a vector. 2AB, based on what we did earlier, 2AB should be 2 times 4, 1, which should be 2 by 4 up here, 2 by 1 down here, which should be 8, 2. In other words, if we want to go from one end of the vector AB to the other, we should travel 8 in the x direction and 2 in the y direction. That means 8 from left to right and 2 from down to up. 8 to the right and 2 upwards, if we want to go from one end to the other. So let's see what happens here. This is one end, and we go 1, 2, 3, 4, 5, 6, 7, 8 units to the right, 1, 2 units up. It seemed to work. Alright? It seems to work. Let's look again at it. 1, 2, 3, 4, 5, 6, 7, 8 units to the right, 1, 2 units up. And there we have the vector that we wanted. It's 8 in the x direction and 2 in the y direction. Alright? So we can just look at vector AB, which is 1, 2, 3, 4, x in the x direction and 1 in the y direction. That's 4, 1. And just multiply. 2AB is a matter of multiplying each number here. The x by 2 up here, the y by 2 down here. 2 4s 8, 2 1s 2. And we get the new vector. Just multiply the horizontal and vertical components of the vector by the scalar, and what we get is the new vector. So that's another look at multiplying a vector by a scalar.